Good morning to all. So this is a robotic experiment. So I have seen the robotic car that is controlled by joystick, and that is controlled using mobile app, and that is controlled automatically. So based on the ultrasonic sensor, it's a self-driving car. It's like that. Okay, it will see the objects, and then it will back off. Okay, and it will move in some other direction. So these are the experiments. So we are giving the workshop on this. Okay, so now what we are going to learn in the next 5 days is using ESP32. We are going to build a car. Okay, and then we are going to use sensors to connect it with the ESP32. Okay, and in the advanced level, we can do experiments like that that Sarist showed on that video. Okay, so using the same ESP32. So the process, the microcontroller that you have is very powerful. You can do a lot of experiments with ESP32. Now we move on to today's session. So the topic is object detection using ESP32. We are going to use ultrasonic sensor. Okay, these are the components required. Okay, the first thing, that big one is there, no? That is called ESP32 microcontroller, and this one is ultrasonic sensor. This it's like an eye, right? Two eyes are there like that. Okay, and then this is buzzer. Okay, these are the main components that you are going to use. With that, we are going to use jumper cable. Okay, so because we are going to use microcontroller today, and we are going to program, and we are going to control everything, we move to the next part. So what is ultrasonic sensor? You have ultrasonic sensor on your hand. Okay, in that you have two eyes like that, isn't it? You can see the two eyes. Okay, it is nothing but a transducer. Nothing but a transducer. What is the use of transducer is, it will send the signal and it will receive the signal. Okay, that is the use of transducer. Okay. So what will happen in how the ultrasonic sensor will work is, what is the use of ultrasonic sensor is, the ultrasonic sensor will calculate the distance. Okay, how it is going to calculate means by sending the ultrasonic sound waves. Okay, we cannot hear the ultrasonic sound waves because it is of higher frequency beyond human hearing. Okay. So we cannot hear that sound, but it is a sound wave of high frequency. This sensor will send, and when it hit a target, so this hash color is called target. When it is hit a target, it will be reflected back. The sound waves will be reflected back, and it is captured by the receiver. Okay, so this is how it will work. It is an instrument used to measure the distance to an object. So using that, we can able to measure the distance of the object. Okay. What is the use of transducer is to send and receive the ultrasonic pulses. The next thing is, in your ultrasonic sensor, you have a T is represented here, that is called transmitting transducer. It will transmit the signal, and this is the receiving transducer. It will receive the signals after reflecting back from the object. And this one is there, no, a tablet like that. Okay, so this is called an oscillator. It will send the high frequency. Okay, it is around 40 megahertz, I think. Okay, it will send the frequency. Oscillator is a device that will send the high frequency signals, or any frequency. It will send the frequency. Okay, it will send the signal. Okay, so that is the working of ultrasonic sensor. How the distance will be calculated is, we know distance equal to speed into time. Or the speed is nothing but the speed of sound. Okay, speed of sound. The speed of sound in air is 344 meters per second. Okay, so that is speed. That is the speed of sound in air. And then time. What is the time means? It is the time taken by the waves to reach the object and to come back into the ultrasonic sensor. So how much time it will take for the ultrasonic sound waves to reach the target and to receive it back by the sensor. So that is the time. Okay, you can measure easily the time because the starting point you know, and then the receiving also you know. From that you can able to measure the time taken divided by 2. Why divided by 2 means it is the time for the transmission as well as for the reception. So we are doing divided by 2. So this is the formula they are using to calculate the distance. We are not going to use the formula to calculate the distance. We are going to do that using the code. But what is ultrasonic sensor means? You just write it down. Ultrasonic sensor is used to measure the distance, okay, of an object using ultrasonic sound waves. Write it down a notebook. Ultrasonic sensor is an instrument that measures the distance to an object using ultrasonic sound waves. You write it. First line you write it. Ultrasonic sensor is an instrument that measures the distance to an object using ultrasonic sound waves. Ultrasonic sensor is an instrument that measures the distance to an object using ultrasonic sound waves. Have you written? If you written, give a thumbs up. Okay, Jeffrey. Others, Tanisha. Okay, you have to write it because we have to understand how it works. So here we have 4 pins, right? We cannot hear the ultrasonic sound waves because it is a sound wave, but we cannot hear. So that is a thing because it is of high frequency, so that the human ear cannot able to hear that. What is the speed of sound waves in air? 344 meter per second. You can use that. You can study that in the physics also. You can remember that. Okay. So this also very important. Distance. How we can calculate the distance with the help of with the speed of sound waves as well as with the time. By multiplying these two, you can able to measure the distance. This is how the distance is calculated in ultrasonic sensor. Okay. Now we move to the next thing. Buzzer. Buzzer is a very interesting component. So many have used the buzzer. The buzzer will produce the beep sound, right? Okay. So that's why it's called buzzer. It produces the sound. How it produces the sound? You know that? It converts electrical signals to sound. Buzzer converts. So here is there no one line. They can write that. This simple line. A buzzer converts electrical signals to sound. So we will pass the electrical signal into the buzzer. The buzzer produces the sound. Okay. So that is the function of buzzer. It produces the electrical signal. It converts the electrical signals to sound. Sound signal. Converts electrical signals to sound signal. Okay, the next thing is microcontroller. So what is microcontroller? You have to understand that microcontroller is like a mini computer. Like a mini computer. What are the things that is there in your computer? CPU is the main component in the computer. What is CPU? Central Processing Unit. After the, where the CPU, in the CPU, what is the other things you have in the CPU? You have if you go deeper into that, you have the motherboard. Okay. In the motherboard, you have lots of other things. Okay. Memory. In the computer, you have a memory. Yeah. And then you have hard disk. Very good. Hard disk is there. But it is externally connected. Okay. Your hard disk is externally connected with your processor. So all those things are called as motherboard. Okay. Through the motherboard only, we can connect all the peripheral devices. Okay, we call that as peripheral devices. RAM, ROM, memory is there, and then you have a monitor. We will connect, and then we have ports, isn't it? So here also you have USB port in your computer or laptop. Through that you can connect the mouse. Through that you can connect the keyboard. Through that you can connect your pen drive. So through the ports only we are able to communicate, isn't it? So you have lots of peripheral device that is connected with your computer. Then that is called as computer. If your computer has processor, your computer has memory, your computer has ports. Okay, and then your computer has Wi-Fi connection is there in the laptop. You have the Bluetooth on your laptop. So your computer has all those. Then only you call that as computer. Similarly, in the microcontroller, ESP32 is a microcontroller that is there in your hand. Okay, it has what? Microprocessor. You have a microprocessor, but here the microprocessor is small power. Okay, but in our computer, the microprocessor is very high processor. Intel i7, Intel i5. Okay, like that you have i9. Like that you have a high power processor because you will do lot of work with the computer. Some way used for editing, some way used for different softwares. Um, so so there is lots of work it will do, right? Multi-purpose it will do. So that's why the processor power is very high in the computer that we have used or laptop. Your microcontroller has everything. Your microcontroller has microprocessor in it. And then your microcontroller has, you'll make a note of it. This ESP32 has 448 KB of ROM. K means kilobyte. Kilobyte of ROM. ROM means read only memory. Read only memory means you cannot change the memory. Okay, the main coding will be stored in the for starting the for booting the microcontroller. We'll use this read only memory. The size of the read only memory is 448 KB. Okay, so what the type that we are using is ESP W room 32. Okay, so that is the ESP variant that we are using. In the chip you can see ESP W room. Okay, and then the processor that we are using is dual core 32-bit LX6 processor. Okay, these are all the things you should know. And then another memory is there that is called on-chip SRAM, static RAM. This is static RAM. RAM means random access memory. So that in this memory only we will store our program and our code. Okay, the size of that is 520 KB. And then flash memory is 4 MB. MB means megabyte. Megabyte. Mega means 10 power 6, I think. Okay. Kilo means 10 power 3. K means kilo. 10 power 3000. That means 1000. Okay. K means byte means 8 bit. Byte, megabyte. Okay. So you will learn more when you grow and you study more physics. Okay. And then static RAM, 16 KB for static RAM, that is for RTC. RTC is for real-time clock. Okay, so this is for fast. Okay, so for fast access, you can store that in this memory. Okay, and then Wi-Fi. You can have the Wi-Fi connection with ESP32, and you can have the Bluetooth connection with the ESP32. So it is like a mini computer that is in your hand. Okay, so that's why the product cost is very high because you have a mini computer. So you can do a lot of experiment with this. We are going to use this microcontroller for 2 to 3 experiment. Okay, you can learn a lot of things with this and you can do a lot of projects with this microcontroller. So it's a very useful thing that is in your hand. Okay, so shall I move to next slide? Okay, so this is the parts of this. So you have lots of, I already told in your component also it is written as ESP W room 32. Okay, so that is the name of our microcontroller. So this is the microcontroller. You can see the chip. This is the board. Okay, the full thing is called board. You have 38 pins here. You can count is 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So here in this side is 19 and that side is 19. So totally how much? 38 pin. So each pin has different functions, multiple functions and different functions. So this is for the voltage regulator, power supply, because we need 5 volt or some cases you need 3.3 voltage. So that will provide by the voltage regulator, and external voltage if you want means you can take, and this is the USB. Through this only you can able to connect with your computer. And then this is boot, and this is also other things, and this is the antenna. So through that you can able to have the Bluetooth and Wi-Fi connection. So here you can see there is a lots of information on this. There's a 38 pin. G&D is ground. So I will give a specific thing that I'm not going to explain all those things because it may take a lot of time. I will explain the simple things that we can use. Okay. So here this is called G&D. Wherever the G&D is there, the first pin. Okay. In your microcontroller is there no this part, okay, is GND. You can see that on your backside of the microcontroller it is written as GND. So that means ground. Okay, you can connect the ground portion on that. Okay, after that GPIO is there, no? GPIO is nothing but general purpose input output. GPIO is nothing but general purpose input output. Through that only we can enable everything. You have to connect with the device. So there it can act as an output pin. Okay, input pin also. There are some sensors is there in ultrasonic also we have the input as well as output. Okay, it will send the signal and then it will receive the signal. When it receives the signal, it is acting as an input pin. Okay, so you can use this pin as an input pin as well as output pin. And there is a power supply. You can see the power supply 3.3 volt you can give. So 3 ground pins are there. You can use any of this, and then VIN is the 5 volt power supply. Okay, and then ADC is analog to digital converter. Okay, some of the signals will be analog and some of the signals will be digital. It will convert and it will send. And DAC means digital to analog. So it will convert the digital signal to analog signal. Okay, we will not use these things, but you can also use that. And then there is some of the touch. You can use this pin as a touch. Okay, and then you can use this pin for serial communication also. Okay, so you have lots of functions. So this is not a simple microcontroller that you have. You can do lot of applications, lot of programs using this ESP32. So they can call it as a node MCU also. Okay, so with that I'm moving on because we have less time. Okay, now take your laptop and then open the Chrome. Okay, in that Google, you type Arduino IDE download. Okay, once you put Arduino IDE, you will have a options like this on your browser, Google browser. Click that Arduino. Okay, after that, you can have a software like this. You can this is the Arduino.cc en software. Okay, in that software you click, you will have this Windows. It will ask what is the options, whether you are using what kind of zip file or MS installer, like that is there different options, Linux or Mac OS. I think if you are using Windows, click the first option, click this version. Okay, it will be easier, it will directly download. Take some time to download. If you are using a Mac, then you have to choose anything over here. Okay, based on your version you have to choose. Now you can see contribute to and download. So if you want to pay Arduino, you can pay, but we don't need to do that. We have free version available. So just download. You put just download. It's saying you can see again it is asking something. Just download. Again give just download. You can save that on your system. Arduino IDE 2.3.2 Windows 64-bit. You just save. Give save, and then your software will be downloaded. So you can say it is taking some time. Okay. Now if you click here, you can go to that location. So once you get downloaded, you will have a folder options like this. Click that folder option and open the file. So once you get downloaded, you have a file like this on your computer. You just click that. When you click that, it gives us like this. Okay, open. Click open, and then it will ask this agreement. Give I agree. Then only it will move on to the next step. And anyone who uses this computer, all users. Okay, give to all users, and then give next, and then click next, and then give agree again, and then it will ask to install. Just give install. Okay, it will ask run Arduino IDE. Click that run Arduino IDE. Check this one if it's not there, and then give finish. So this is Arduino IDE setup. What is the IDE means? Integrated Development Environment. Okay, so in that only we can able to give code and then you can run the code, and then you can able to upload that on your ESP32. Once you've done that, you will have a screen like this. So this is the screen where you can type your code. Now, after doing that, we have to do few more things for the environmental setup that we have to do. Okay, because our processor is ESP32, our microcontroller is ESP32. There is a lot of there is Arduino is there. You can use the Arduino also for you can use this IDE for Arduino also. Okay, so in the ESP itself, we have lots of variants, different. Now what we are using is W room 32. We have different types of variant in the ESP32. So for that we have to set up which one. So click this one. Okay, in the screen, click this option. Second one, not the first one, second one. Once you click that, you will have board manager. Everyone seeing that? In that, what we are using is ESP32. Type is all. ESP32 is that we are using. Okay, make sure here you have ESP32. Okay, once you have once it's the installation is over, then we can move to the library. Here only all the libraries of ESP32 will be installed on this system. That's why it will take some time, because it is installing all the libraries. You can see it will install all these libraries into the system. Okay, now it says platform ESP32 is installed. Then we can move to this one. Now here you have to type ESP32, ESP32, and then install. Okay, ESP32 server, and then install. It says installed. Now it's installed. Now it's showing you can remove. After that, select other boards and ports. Okay, so here go to top, select other boards and port. In that ESP32, then DEV module. So see that ESP32 DEV development module. Okay, and then ESP.
First click on library. Next search button. ESP32
servo.
First
Okay. And then they will install. They will install that. Okay, after that, next step.
Next step. Click on select board manager. Already selected. Select other board and port.
Okay, they have done that also. Okay.
Search bar ESP32.
ESP32
DEV module.
Module. Okay.
Once selected, come on ports.
But do you get ports?
Sir, already வந்து 2 ports இருக்கும். Some laptopல வந்து இருக்காது.
Yeah.
My
laptop also it's not there.
பண்றப்ப ஒரு port number வந்து visible ஆகும் சார்.
Okay, you should just show them how to plug in the board with the laptop first. Then only they can able to see the port. See how they are connecting. Take a USB cable and connect one on your system, and then other end of the P type to your ESP32. Okay, once you done that, you will get a red light. That means your ESP is now powered. Okay. Okay.
While connecting, it's blinking and then it's turned off.
வேற இன்னும் மற்றவங்கலாம் உங்களுக்கு காமிங்க. Okay. Go to tools.
ஃபர்ஸ்ட் வந்து என்ன பண்ணா இந்த ESP3 dev module இருக்குல்ல சார், அதை கிளிக் ஆன் பண்ணணும். கிளிக் ஆன் பண்ணிட்டு செலக்ட் அதர் போர்ட் அண்ட் போர்ட் கிளிக் பண்ணு. ஒன்ஸ் கிளிக் பண்ணனும்.
ஃபாலோ பண்ணுங்க.
சரி, ஓகே சார். ஃபர்ஸ்ட் வந்து இந்த ESP32 dev நான் ஆல்ரெடி கனெக்ட் பண்ணதுனால எனக்கு இது விசிபிள் ஆகுது. அதர்ஸ் வந்து செலக்ட் போர்ட் மட்டும் தான் விசிபிள் ஆகும். ஒன்ஸ் கிளிக் பண்ணோடனே செலக்ட் அதர் போர்ட்ஸ் அண்ட் போர்ட்ஸ். சர்ச் பார்ல வந்து ESP32 click on ESP32 dev module. After clicking to plug in the USB, sir.
They already plug in.
Plug out பண்ணிட்டு plug in பண்ணு சார். ஏன்னா visible ஆகணும்.
Okay. Once you just plug out the USB and then plug it again. Then only you will have a indication like this. Everyone after selecting this ESP32 dev model, just plug out your USB and then plug in again. You will have one port option here. Everyone get that one? Can you see the tick mark? You just plug out your USB from the system and then plug in again on the same location, same port. This tick mark, then click OK. Select that one and click OK. That means you have connected your ESP32 on that particular port. That is the thing that you are doing. Like the correct port where you have connected your ESP32. Shall we move on to next step? I will explain this code later. First, you do the connection. Shall we move to next step? After selecting the port, okay, like sir told, you just copy and paste your code on this document. Okay, once you paste it, go to the connection part. So this is your ESP board. So through this only you have connected the computer, and then you have to connect this using like this. Okay. Okay, so sir, this is the sir has told you. You can see this in the buzzer. You just connect the wires like this. Okay, this is female port. Okay, connect that anywhere to the buzzer. After that, you have to connect take 4 jumper wire and then connect with the 4 terminal of this. Connect in this ESP. Okay, for reference, you can see this one. So VCC to the last one. Okay, and this is the ground. So any ground you can choose, any VCC you can choose. It's not an issue. And then for buzzer you take 1 ground, and for trigger and echo. Okay, trigger means we are sending the trigger point, and then echo means reception. Okay, after that and ending will be represented by trigger and echo, and then connect this. So otherwise you can see this one, and then you can easily connect. So these two are trigger and echo, and the middle one is the trigger and echo. The connection according to this, you can see the number on your itself. This is clock. Okay, clock, this one is clock. At the back side of the board you can see the numbers. At the back side of the board you can see the numbers. Ranjit, you can show at the back side of the screen, you can see the numbers. G and D, this is the ground represented as G and D. So here also ground in the ultrasonic sensor. Connect 1 wire to this one and connect to this pin. After that VCC, connect to this one, and in your board there is 5 volt. Okay, there will be 5 volt. Is represented as 5V. Here in my board it is mentioned as 5V. Connecting there. Here you can see at the back of the board, sir is showing you connection. Okay, first ultrasonic மட்டும் காமிங்க சார், அதுக்கப்புறம் பஸ்ஸருக்கு போகலாம். அதுக்கப்புறம் trigger to which point? Trigger to the 4 lines are there. How sir is connected there. Trigger to where?
Trigger to 5th pin, sir.
5th pin. Trigger to 5th pin. You have to see the 5 numbers. You can see the 5 there on the board. Sir is connecting there. And echo to 18th pin. Echo to 18th pin.
8th pin, sir. 8th pin.
18th தானே?
18.
Next ground வந்து
ground to
GND இருக்கும். ஏதாவது ஒரு கிரவுண்ட்ல குத்துருங்க. GND இருக்கும். 3 இருக்கும். 3 grounds are there. Any one ground you give. After that
VCC.
Once you VCC
connect to 5
show
volt
that
or
5 volt or 3.5. So this is how you have to connect ultrasonic sensor, and then buzzer you take.
Buzzer VCC pin to connect the 9th pin, sir.
Buzzer வந்து
VCC
to the VCC வந்து 19th pin. 19th pin. Ground வந்து
black, connect to ground.
ஓகே, சார் பண்ணிட்டாரு பாருங்க. black வந்து கிரவுண்ட்ல கனெக்ட் பண்ணுங்க. இப்போ முடிஞ்சா? ஓகே,
I have already
சார் இப்போ ஓகே, இப்போ நீங்க பாத்தீங்கன்னா கிரவுண்ட் வந்து கனெக்ட் பண்ணிருக்கோம், 18th பின் கனெக்ட் பண்ணிருக்கோம், 5th பின் கனெக்ட் பண்ணிருக்கோம், அதே கிளாக் இது வந்து 19th பின். சிம்பிள் தான் கனெக்ஷன், ரொம்ப பெரிய டிஃபிகல்டிஸ்லாம் கிடையாது.
ஒன்ஸ் கனெக்ஷன்ஸ் எல்லாம் ஃபினிஷ் பண்ணோடனே வெரிஃபை பட்டன் வந்து கிளிக் பண்ணணும். ஆஃப்டர் கிளிக்கிங் நம்ம ப்ரோக்ராம் வந்து வெரிஃபை ஆகும், கரெக்டான ஃப்ளோவில் இருக்கா அப்படின்னு செக் பண்ணுறது.
So where is the verify button? That is on the
கார்னர் சைடு சார், லெஃப்ட் கார்னர்.
corner. You can see verify. Click that. Once you click that, it will take some time to verify all the code.
ஒன்ஸ் வெரிஃபை ஆனோடனே இந்த பாப்அப் மெசேஜ் வரும் சார்.
You can see the top of message there.
ஒன்ஸ் வெரிஃபை வந்து கிளிக் பண்ணிட்டீங்கன்னா வெரிஃபை முடிஞ்ச உடனே இந்த மெசேஜ் வந்து விசிபிள் ஆகும். எல்லாருக்கும் வந்ததா?
Okay, next is the next point, upload. See the top left. Okay, upload.
Once click upload button.
It's compiling, compiling and writing that on your ESP board.
Once upload ஆனே இந்த மாதிரி ஒரு மெசேஜ் வந்து விசிபிள் ஆகும் சார். ப்ராப்பரா எந்த எரருமே இல்லாம இருந்தா.
Okay.
விசிபிள் ஆனே அவங்க செக் இட் பண்ணலாம் சார்.
When you keep your hand closer to the sensor, it will detect the object and it will ultrasonic sensor calculates the distance between the target and the sensor. Okay, when based on the distance you can vary on the program. You can make the distance very large or you can make the distance very close based on the coding only the distance. Okay, at what distance you want your buzzer to blow, we can able to code that. Now listen the coding part. I am going to explain the code. You can see on the screen. So what you have to do is I am giving a trigger pin 5. Okay, that means to the 5th pin I am connecting the trigger pin. Define is the statement. So one person asked, sir, shall we use MicroPython like that? You can use that. You can use it. Okay, it's not a problem. Okay, you can use the MicroPython also. Python, Arduino is there, so you can use it. Now I will explain the code for you. Just go to the code, open the Word document or system, and echo pin is I am connected to the 18th pin and buzzer pin I connected to the 19th. So this is the pin I have selected. You can use any other GPIO pin. It's not that you have to use 5, 18 and 19. You can use any other GPIO pin that is on your ESP32. That's the first point. And then void setup. Okay, so this is the baud rate for communication. Okay, it's a common one. You can use this number for communication. It's a frequency through which your system can able to communicate. Okay, it can able to transfer and receive the data with this rate. Okay, it is common. Okay, and then trigger pin output. So trigger is an output pin. I am making that as an output because we are sending that we are sending that from the processor. Okay, output means sending from the microcontroller. Input means getting into the microcontroller. That is called input. Output means sending out. Input means getting into the microcontroller. So trigger is an output pin. Okay, through that and echo is the input pin. It receives and it is sends. Okay, and buzzer is an output pin. Am I right? Okay, the buzzer is an output device. Okay, you have to mention based on the device whether it is an output or input. LED is an output or input?
Output device.
Yes, output device, because we are sending the signal into the device. If we are receiving the input means then it is a input device. Echo pin is an input, that means we are receiving from the sensor. Trigger is the output, we are giving that into the sensor. Keep that in mind. After that, digital write. So this is the command that we are going to use for this. Okay, and we are going to read the ultrasonic distance, the function name, and digital write. Digital write means what? Trigger pin. So trigger pin is, what is the pin number for the trigger pin? Is 5. Okay, so 5 here comma low. Okay, when it is low, then only it will sense the output. Okay, the delay seconds you can give in microseconds as 2. If you want to increase, you can increase. And the trigger pin is high. Okay, and then trigger pin is low. So what this actually does is it will send you the distance. Okay, initially the trigger pin is low, and then trigger pin is high, and then trigger pin is low. That means we have sent the signal, and it detects the object, and it will detect it again. So it is like a waveform. Okay, so triggering the sensor, and then triggering means switch on the sensor. The sensor will send the signal. Okay, and then it will get back the signal, and the sensor will off. So it is one cycle of communication. Okay, after that, during that time, it receives the echo, isn't it? Echo is the signal's length. Based on this only, we are calculating the time into distance using the formula. Okay, after that, it will return the distance. Okay, that distance is called is sent to the distance. Okay, variable. We have to mention that in the centimeter. We are keeping as 10 centimeter. Okay, we are not keeping much. For below 10 centimeter, it will be detected. If you want to keep 20 centimeter means you can make this to 20. That means coming to the below 20 centimeter, the buzzer will high. Okay, else the buzzer will not blow. Low means it will not blow, turn off. Okay, it's a simple one. Okay, it's not a difficult one. So here this part is the ultrasonic part. We are sending one signal, okay, and then receiving one signal. Okay, after that we are converting that into distance, because we have calculated only the time of the pulses. So calculate the distance, we have to multiply the speed of sound with the time. After that, so this is the time it will take. So the same formula. After that, what? We are sending that into the variable distance. After that, we adjust the condition. Below 10 centimeter blow, below 20. If you want to vary means you can vary. You can make it 20, and then you can check whether below 20 centimeter it is blowing or not. So that is the quick explanation of the program. Okay, at the end of the session.